Welcome to the lecture on measuring threats. I will start by talking about how this is hard. I will then give an example in relation to target selection. We'll then go over some things to think about when doing measurement studies, namely displacement and reasons why concentrations may be seen. We can't measure the effectiveness of security controls unless we control for differential targeting by threat actors. For example, banks invest loads in security but still suffer frequent losses. This doesn't mean the investments are counterproductive. Some academic studies show this, but instead we're not controlling for a confounding variable. Studying attackers helps us understand and quantify different threat levels. For example, Anderson et al. Provides aggregate estimates of cybercrime costs. However, the concept of a threat model is a statistical abstraction, not something that's easy to measure and model. Attackers don't think like this, and gathering data is difficult. In particular, understanding relative threats can be difficult. What we can do in some instances is measure how attackers go about target selection. Prior research into Zeus, a common banking Trojan, found that many attacks are concentrated. An analysis of 11,000 configuration files targeting 1.2 million URLs found that about 15% of domains attract 90% of attacks. Furthermore, code similarity was high at 90, suggesting that attackers were sharing, selling, or stealing configuration files amongst themselves. This hypothesis was later supported by Hutchins and Clayton, who also found evidence of configuration files being traded amongst actors. We can also use theoretical approaches to reason about threats more generally. You were introduced to the rational choice perspective in an earlier lecture. This outlined that offenders may calculate the perceived costs and benefits when choosing to commit crime, and it provides a useful model for thinking about target selection. I undertook qualitative research interviewing offenders involved in unauthorised access and computer fraud offences to explore how they selected their targets. Findings revealed that in some cases, offenders targeted victims known to them, others chose targets indiscriminately by chance. Overall, there were indications they selected targets perceived to be easy, those with known vulnerabilities, and targets providing a high reward. There are a number of things to think about when measuring cybercrime threats. First, we'll consider displacement. Online, offenders do not have to physically relocate in order to displace their activities. Displacement occurs when crime prevention activities result in crime changing and evolving. Smith et al. Characterised the different types of displacement that can occur online. These included moving to new locations, targets, methods, offenders, or offence types, and these are explored by Hutchins, Clayton, and Anderson in the context of website takedown. Displacement to new locations can be seen with phishing, which is automated, and away from hosting providers who are more responsive to takedown requests. Displacement to new targets can be seen when offenders start targeting a new brand, use types of scams, or diversify their targets, such as phishers diversifying from banks to also target web providers, cloud storage, and Bitcoin wallet providers. Offenders often displace to new methods or different ways of carrying out their attacks. For phishing, they may change the types of domains they register. Some phishing groups have come up with more complex methods to try to resist takedown, such as the Rockfish Gang and the Fast Flux method. Displacement to another offender is typified through the Silk Road example, where after the arrest of Ross Ulbricht, a new Dread Pirate Roberts operated Silk Road 2. Offenders can also displace to new offence types, for example, from moving from phishing to malware. Another consideration to take into account with measurement studies is understanding the effects of concentrations. Clayton et al. Point out that researchers often observe concentrations in cybercrime data, leading them to recommend interventions designed to take advantage of these choke points. Concentrations are often seen with infrastructure providers such as ISPs, payment providers, domain name registration, hosting providers, and the reuse of code. They argue that there are economic reasons for why these concentrations arise, such as comparative advantage, network effects, economies of scale, winner-take-all dynamics, and barriers to entry. However, most importantly, they caution that while some concentrations are due to economic efficiencies taken by offenders, not all concentrations are real. Some may be due to measurement bias, others due to confounding variables such as population size, and others may be due to only including a small number of participants and not measuring the activities of others.